Today, we're going to crack open a piece of ancient technology that is so advanced, it almost feels like it shouldn't exist. We're not talking about a weapon or some giant monument. We're talking about a lock. But this isn't just any lock. This thing hides a secret that's literally billions of combinations strong.
Just take a look at this number, 4,294,967,296. Let that sink in for a second. What could this possibly be?
Well, get this. That's the number of unique combinations on a single mechanical lock. And no, this isn't for some high-tech digital vault. This lock was built back in the 12th century, during the Seljuk Empire. No keys, no electronics, just pure, unadulterated, mechanical genius.
And that, right there, is the million-dollar question. Or, I guess, the $4 billion question. How could an ancient civilization possibly create a combination lock with a level of security that honestly gives modern devices a run for their money?
Okay, so here's how we're going to unpack this whole mystery. First, we'll journey back in time to the world where this thing was even created. Then, we're going to examine the device itself, the box, the dials, the whole shebang. After that, we'll peek inside the mechanism to see how it all works. Then we'll do the math to see how they got to 4 billion combinations. And finally, we'll ask what this incredible object really tells us about our own past.
So, to really appreciate this marvel of engineering, we first need to understand the world it came from. Let's set the stage.
You see, this lock wasn't some kind of fluke. It was a product of its time, the great Seljuk Empire in the 12th century. And this was a genuine golden age of scientific and artistic innovation. This was a culture obsessed with precision and ingenuity, exactly the kind of environment where a brilliant idea like this couldn't just be born, but could actually be built.
Okay, so that's the history. Now let's get our hands dirty, figuratively speaking, and look at the device itself. What did this ancient safe actually look like from the outside?
So on the outside, it's a pretty compact metal box. But what immediately jumps out at you is the face. It has this series of rotating dials, and each one is marked with different letters or symbols. But notice what's missing. There is absolutely no keyhole. None. The only way you can possibly interact with this lock is through those dials.
But the outside? Well, that's just the interface. The real genius, the secret to its mind-boggling security, is hidden deep inside. So let's take a look at that mechanism.
Now inside, the concept is just beautifully simple. For every external dial you can see, there's a matching cylinder hidden inside the lock. They're a pair. So when you turn a dial on the outside, you're also rotating its partner on the inside. This direct one-to-one connection is the entire secret.
And this right here is the core principle, rotational alignment. Each and every one of those internal cylinders has a single precisely cut notch. The whole device is locked by a solid bar that just rests against these cylinders. The box will only open when every single one of those notches lines up perfectly, creating a channel for that locking bar to slide into. It's that simple and that brilliant.
So the unlocking sequence is just super elegant. You turn each dial to the correct character in the combination. Inside, the connected cylinders spin into position. When you set that final correct character, all the notches align, and boom, you have a perfect groove. The locking bar then slides free and the box is unlocked. Simple in concept, but incredibly difficult to brute force. Which brings us right back to that insane number. How does this simple alignment idea lead to over 4 billion possible combinations?
The genius here isn't about making one super complex part. Not at all. It's about multiplication. The lock's massive security doesn't come from a single intricate gear. It comes from the compounding power of many simple, identical parts all working together.
Okay, let's break down the math because this is where it gets really cool. Let's just say each dial has 16 possible characters. With one dial, you've got 16 combinations. Easy. Add a second dial and it's 16 times 16. That's 256. With 4 dials, you're already at over 65,000 combinations. But the Seljuk lock had 8 dials. That's 16 to the power of 8, which gives us that incredible 4.2 billion figure. And this chart just visualizes that exponential leap perfectly. I mean, look at the jump from just 4 dials to 8. The security doesn't just double, it explodes into the billions. This is the power of combinatorial mathematics, and it was being harnessed by engineers over 800 years ago.
So we've seen how it works, and we know where the numbers come from. But what does it all mean? What does this incredible device from the past really tell us today?
I think this quote just captures its essence perfectly. The Seljuk lock is so much more than a clever gadget. It's physical proof of an advanced understanding of mathematics and precision engineering. It really forces us to rethink our assumptions about what was technologically possible way back when.
So, what are the big takeaways here? First, that our assumptions about the primitive past can be wildly wrong. Second, that sometimes immense security can come from simply multiplying simple ideas. And maybe most importantly, we're reminded that true engineering genius, the kind that beautifully merges math and mechanics, is absolutely timeless.
And that leaves us with a really fascinating final thought. If a lock this sophisticated could exist 8 centuries ago, it just makes you wonder, what else from our past have we totally forgotten about? What other marvels are just out there, waiting to be rediscovered and understood?